In this video, we're going to be talking about manometers. Manometers are tools used to measure pressure. So it will measure two different pressures, in this case P1 and P2. I want you to think of a manometer as a seesaw or a balance, where P1 is pushing down on one side of the balance and P2 is pushing down on the other side of the balance. So as you can see, P1 in this case is lower than P2. So P1 is a lot lower than P2, so it's tilted towards P1. Our balance would be tilted towards P1, and P2 would be higher if it was a seesaw. So this means that P1 must have a bigger pressure. It must be a larger pressure than P2 because it pushes down on that mercury harder than P1. Than P2. Please make the following adjustments to your worksheet. So number 7, I've changed the units to mmHg. Number 8 should say 780 mmHg and 1128 mmHg. Number 9 should say 98.4 mmHg and 58 mmHg. Number 10 should say 735.5 mmHg, and then change your ATM to mmHg. Number 11 should say 871 mmHg, and number 12 should say 75.2 mmHg. I apologize for those mistakes. So now let's talk about how to solve these problems. So in each case, you are looking for X. So in this case, our X is what is our pressure that's pushing down on that side of the manometer. We know what pressure is pushing down on this side. That's going to be 125.6 millimeters of mercury, but we don't know how much is pressing on the open side. This side is the open side. But when we think about that seesaw, that balance, I want you to notice it is totally balanced. The level of mercury on both sides is completely balanced, which means the pressure on one side must be equal to the pressure on the other side. So if this side has a pressure of 125.6 millimeters of mercury, our other side must have a pressure of 125.6 millimeters of mercury. They have to be equal because the level here is balanced. Well, it's not always balanced. In this case, in number 8, we're looking at a higher mercury on this side than on this side. So our balance kind of looks like this. So we know that this side's pressure right here, must be higher, must be bigger than the other side. Well, we need to figure out how much bigger. Well, we know that this pressure is 780 and this pressure is 1128. So I know that 780 plus something, plus this distance right here, because if we had that distance, it would then be equal. So plus my X has to equal 1128. If these were equal, right, if I added this X, then my pressures would be equal. So this statement would be true. So I'm solving for X, so I subtract 780 from both sides, and I find my X. In this case, X is equal to 348 mmHg. So what this means is if I added 348 millimeters to this side, then my level of mercury would be equal. So that's how I got my X. It's the difference between these two sides. In number 9, I'm given 98.4 millimeters of mercury on one side and 58 millimeters of mercury on the other side. So we have 98.4 millimeters of mercury pushing down on this side, and the pressure is 58 millimeters of mercury pushing down on the other side. Notice 98 is a bigger pressure, so it's lower. 58 is a smaller pressure, so it's higher. So go ahead and, just like the previous example, solve for your X. Pause the video while you do that. Now in number 10, we are looking for what is the pressure pushing down on the open side. So I'm told that 735.5 millimeters of mercury is pushing down, and it's pushing down hard enough that 208 millimeters of mercury pop up on the other side. So my seesaw kind of looks like this. So I know that this side has a bigger pressure than this side because my millimeters of mercury pops up near the open side. So how much bigger? Well, it tells us right here. 208 millimeters bigger. So I know that X plus the 208, so this pressure plus this pressure would equal that pressure right here. So that would equal 735.5 millimeters of mercury. So now I need to solve for my X, so minus 208 from both sides, and I can solve for my X. And my answer is 527.5 millimeters of mercury. I can check my answer because I know that this side right over here has a bigger pressure. It's pushing harder on that mercury. That's why the mercury is lower than this side. And I also know that 735.5 is bigger than 527.5. So that's a good way to check. So go ahead and do numbers 11 and 12. Pause the video while you do that. 13, 14, and 15 are going to be a little bit trickier because now we have different units of pressure. Not everything is mmHg. So we're going to need to convert between units of pressure before we solve. So in this case, we have a 1.25 atm, and we know that this difference here is 510 millimeters of mercury. I also know that this level is higher than this level, so this pressure is bigger than this pressure. It's pushing that mercury down harder. So the first thing I need to do is I need to convert this into millimeters of mercury, because again, this is mercury, so the only unit we can use when we use manometers is millimeters of mercury. So 1.25 atm times something over something has to give me some millimeters of mercury. So I know I need to get rid of atm, so that's going to go on the bottom, so that way these units cancel. And I know I need to get to millimeters of mercury, so that'll go on top. From the previous video, you should know that 1 atm is equal to 760 millimeters of mercury. So when I do this conversion, I'm multiplying 1.25 times 760. Since 1.25 is bigger than 1, I know that my answer should be bigger than 760, because if I had 1 atm, I would have 760 millimeters of mercury. And indeed, my answer is 950 millimeters of mercury. So now I'm ready to do this, this problem. So I have 950 millimeters of mercury pushing down hard enough that there's a difference of 510 millimeters of mercury. So I know that this pressure here, my X, has to be smaller than this pressure. So 950 millimeters of mercury minus my 510 millimeters of mercury will give me my X. Because 510 plus my X should equal this pressure. So when I solve that, I get 440 millimeters of mercury. But I don't want it in millimeters of mercury. I need it in kilopascals. We didn't talk about kilopascals in the last video, but that's another unit of pressure. And 101.3 kilopascals is equal to 1 atm, which is equal to 760 mmHg, which is equal to 14.7 pounds per square inch. So these are 4 different units, all meaning pressure. And now we just need to convert from 440 millimeters of mercury into kilopascals. So in this case, I'm trying to get rid of millimeters of mercury, so that goes on bottom, and I'm trying to convert it into kilopascals, so that's on top, and I know that 101.3 kilopascals is equal to 760 millimeters of mercury. So I'll put 101.3 kilopascals and 760 millimeters of mercury. So now I multiply by my numerators and divide by my denominator. So 440 times 101.3 divided by 760 gives me 58.647, but I want two significant figures. So I'm going to go with 59 kilopascals, and so that's my X. Make sure you include your units. Okay, go ahead and give the other two a try, 14 and 15, and show all of your work. Do your best, and thank you for doing such a good job today.